So today we'll start Rstp. So first of all, Rstp stands for Rapid Spanning Tree Protocol. Rstp stands for Rapid Spanning Tree Protocol. It is IEEE 802.1W, an open standard protocol. Next, it has fast convergence than traditional STP, spanning tree protocol. Next, root bridge, or we can say root switch, root port, and designated port election method is same as traditional STP. Port fast is required in Rstp. Any doubt up to these points?
No, sir.
Okay, very good. So we have either Cisco device or non-Cisco device. We have either Cisco box or non-Cisco box. So in Cisco device, we have Rapid PVST plus, and in non-Cisco we have Rstp. Clear?
Yes, sir.
So now we discuss about port states in Rstp. Port states in Rstp. So what we have learned in STP? STP port states. Disabled, blocking, listening, learning, and forwarding. We have 5 port states in STP. Okay,
Yes, sir.
but in Rstp we have discarding, learning, and forwarding. So discarding is of 15 seconds, learning is of 15 seconds, and then forwarding. Discarding is of 15 seconds. And learning is of also 15 seconds. Actually, these three states are known as discarding in Rstp. That means disable, learning, listening, and learning of Rstp is equivalent to discarding in Rstp. Clear?
Yes, sir.
We know initially in STP it takes 30 seconds to converge a new topology, and here in Rstp we are seeing that discarding is of 15 seconds and learning is of 15 seconds. Then how Rstp convergence is faster than STP? Okay,
Yes, sir.
so we'll discuss it. Now let's discuss about port roles. Port roles in Rstp. Port roles in Rstp. So in STP we have designated port, which is always in forwarding state. We have root port, which is always in forwarding state, and we have alternate port, which is in always blocking state. Any doubt?
No, sir.
Now in Rstp, what are the port roles? We have designated port, which are always in forwarding state. We have root port, which are always in forwarding state. And we have alternate port and backup port. Both are always in blocking state. Both are always in blocking state. So actually the role of alternate port in Rstp is break into two parts. One is alternate port and another is backup port. But where alternate port is used and where backup port is used. So actually we can say alternate port is the secondary root port and backup port is the secondary designated port. Okay.
Yes, sir.
Alternate port is a secondary root port and backup port is a secondary designated port. So we consider two topologies. So it is my switch 1 and it is my switch 2. So we enable Rstp in both switches. We enable Rstp in both switches. So let's consider this is my root bridge. And we know all the ports are designated port in root bridge. Okay. And this is non-root bridge, so it must have a root port. In switch 1, all the ports are designated port and in forwarding state because it is root bridge, and switch 2, as it is a non-root bridge, it must have a root port, and another is alternate port, and another is alternate port. Okay?
Yes, sir.
So what is the role of alternate port here? Secondary root port. That means if this port goes down, alternate port immediately takes the responsibility of this port. That means this port become root port immediately.
Root port.
Clear?
Yes, sir.
What is alternate port? I think it is clear now.
Yes, sir.
Now consider what is backup port. So consider this is switch 1 and this is a hub. This is a hub. This is switch 1 and this is hub. So switch 1 will become root bridge, and both of its ports become designated port. Now what will hub do? Receives a BPDU from this port, will forward from this port. Receives a BPDU from this port, will forward from this port. Because we know hub is a layer 1 device. Okay?
Yes, sir.
In such scenarios, out of these two ports, one port will be backup port. One port will be backup port. In such scenarios, one port will be backup port. And we know what is backup port is.
Yes.
It is secondary designated port. Okay? Any doubt up to this point?
No, no, sir.
Very good. If your actually, what will happen if your STP's conception is clear, then Rstp will be much easier for you. Okay.
Yes, sir.
So the actual games played in RSTP by its BPDU. RSTP BPDU. We know BPDU stands for Bridge Protocol Data Unit.
Data unit.
A type of STP message exchange between switches to share the information of the topology. Very first point you have to remember, there is only configuration BPDU, no TCN BPDU. There is only configuration BPDU in RSTP, no TCN BPDU in RSTP, and every switch can generate BPDU in RSTP. Okay.
Yes, sir.
We know in STP only root switch can generate and forward BPDU. Only root switch is able to generate BPDU, and rest of switches can forward this BPDU to other switches. But in RSTP, it can be generated by any switches in the topology. So, discuss about the fields in RSTP BPDU. The first field, we know it is protocol ID, protocol version, type, flag, root bridge ID, cost, designated bridge ID, designated port ID, message, forward delay timer, messages, hello timer. So these are the fields in BPDU we have already read in STP. Okay.
Yes, sir.
So first of all, you have to remember there is no use of maxes timer in STP. RSTP, sorry, in RSTP. In STP, it is 20 seconds. In STP, maxes timer is what?
20 seconds.
In STP, maxes timer is 20 seconds. But in RSTP, there is no maxes timer is used. The maxes timer is 20 seconds in STP. What does it mean? If a switch stops receiving BPDU on one of its ports, it will wait for 20 seconds to expire that BPDU on that particular port. Okay? But what will be in the case in RSTP? In RSTP, if 3 consecutive BPDUs are missed on a port, then the BPDU will be expired on that port. So we can say here it is 6 seconds. Clear?
Yes, sir.
Forward delay timer is same, 15 seconds. Hello timer is sent 2 seconds. What is message age? Message age means message age defines how far or how long, you can say how far a BPDU can go in a layer 2 network. That is, it is almost equivalent, or you can say it is similar to TTL in IP header field. Actually, the value of message age is, the default value is 7.
স্যার এটা একদম বলবেন।
Message age is similar to TTL field in IP header as per, if we consider their function. It defines how far a BPDU can go in a layer 2 network. The default is 7. I'll explain you. It is decremented by 1 in every switch, and when it becomes 0, it is discarded. Okay. In layer 3 network, what we have seen, suppose this is a router, this is a router, this is a router. It is router 1, it is router 2, and it is router 3. Suppose router 1 generates a packet in which the default TTL value is 10 or 128. It depends from which ways the IP packet is generated. Okay. So this packet will come to R2. R2 will forward this packet to whom? R3. R2 will forward this packet to R3, But before forwarding, it will
decrease the
decrease the TTL value by 1. So what is the purpose of decreasing the TTL value? So that if by chance a packet gets entered in a loop, that packet should not be stuck in a loop forever, because the router which receives a packet with TTL value 1 and when try to forward that packet to another router, the TTL value becomes 0, then that router will discard the packet. That means suppose this router forward this packet to R2 with TTL value 1. R2 receives a packet with TTL value 1, and when R2 is ready to forward that packet to R3, it will decrement that value by 1 and it becomes 0.
0.
R2 will not forward that packet to R3 because TTL value 0 means this packet is no more eligible to exist in a layer 3 network. Basically, it is used to prevent layer 3 loops. R2 will drop that packet. The packet will be discarded. The same thing, almost the same thing is done by message edge. If in a layer 2 network there are, suppose, so if a BP2 is generated by this switch, and the message edge is 7, this BP2 will be forwarded to this switch. When this switch forward this BP2 to its directly connected switch, it makes the message edge to 6. Message edge to 6. When this switch forward this, it will be 5. It will be 4. It will be 3. It will be 2. It will be 1. And it will be 0 if this switch wants to forward this BP2 to any other switch. In that case, this BP2 will be discarded by this switch because message edge is 0. Clear? Any doubt up to this
না
point?
স্যার স্যার একটা কোশ্চেন আছে
Say.
যদি এই টোপোলজিটা ট্রি স্টাইলে থাকে
That's why we make topology in such a manner. That's why we make that a topology in such a manner. Because in our enterprise network we have core switch, then we have distribution layer switch, then we have access layer switches. Okay,
Hmm.
and they are connected in this way. If you want to add any another access switch, we can add here under any distribution layer switches. Let it is core 1, core 2, distribution 1, distribution 2, distribution 3, access 1, it is access layer switch, access 2. Access layer switch means where end user are connected. Access 3, access 4, access 5, access 6. So if we want to add any access layer switch, we can add that switch under any distribution layer switch. Okay?
Yes, sir. আমার আর যে কোশ্চেনটা আমি বলছিলাম, ধরুন আমার কোর লেয়ারের C1 যে সুইচটা আছে ও আরএসটিপি মানে বিপিডিউ দুটো জেনারেট করছে, D1 কে একটা পাঠাচ্ছে, D2 কে একটা পাঠাচ্ছে।
ওকে,
এর হেডার স্টাইলটা কেমন হবে? মানে তখন এর বিপিডিউ যে এই যে এক করে ইনক্রিজ ডিক্রিজ হয়ে যেত, মানে এখানে কি রকম, এর কাছে কি প্যাকেট আসবে আর এর কাছে কি প্যাকেট আসবে?
C1 generates a BPDU and sent to D1 and D2. Both packets are same. Both BPDU frames are same. No change. There is no difference between them. If that BPDU is generated by C1. If that BPDU is generated by C1, then both BPDUs are same. Then what is your question? Clear? So I think maxes timer, why we don't need maxes timer 20 seconds in RSTP, it is clear, and what is messages, it is also clear.
Yes, sir.
Actually the important part of this BPDU is this field, flag field.
Flag?
Yeah. This field plays a major role in RSTP. Basically, flag field is of 8 bits. Flag field is of 8 bits.
তার মানে এটা শুধু 0 বা 1 কে স্টোর করে রাখতে পারে?
Obviously. So what we have, 7, 6, 5, 4, 3, 2, 1 and 0. So this field is TCN bit used for TCN BPDU.
Sure.
It is not used in RSTP. This field is used for TCN ACK. That means when there is an TCN acknowledgement, this bit will be on. It will be not used in RSTP. These are unused in STP. In STP, these are unused. But in RSTP, these are bits which have some significance. This is proposal bit. This is proposal bit. This is agreement bit. This is agreement bit. These two bits defines the port role. This is learning. And this is for forwarding. Clear?
এক মিনিট দাও না স্যার, একটা ছবি তুলে নিই একটু। ফ্ল্যাগের সম্বন্ধে আমার এতটাও মানে ইয়ে ছিল না।
So this field plays a major role in RSTP. So now we will discuss in depth about port role. These two bits, okay? So it is clear? Any doubt?
হ্যাঁ স্যার, হ্যাঁ, না না না।
Very good. Now consider bit 5 and 4. For what purpose it is used? Port role. Okay? If both are 0, when the both are 0, that is reserved. Clear? If it is 0 and it is 1, that means it is alternate or backup. Okay?
স্যার এই ফ্ল্যাগটা আমি দেখতে পাবো কি করে?
You have to capture the packet?
আচ্ছা, আদারওয়াইজ দেখা যাবে না ফ্ল্যাগটা?
No. It is reserved. And it defines it is DP, that means designated port. Clear?
হ্যাঁ স্যার।
Any doubt?
না। একটু লোড করুন স্যার।
Okay, okay.
হয়ে গেছে।
So how RSTP convergence will happen? How RSTP convergence will happen? So it is my switch 1, it is my switch 2, and they are connected with a physical media. It is my switch 1, it is my switch 2. So let's consider both these ports are down but switches are up. Okay? Hello?
শুনতে পাচ্ছি স্যার?
Both switch 1 and switch 2 are up but their ports are down. So in very fast time both assumes they are root bridge. This ports gets up, okay, and immediately moves to discarding state. In which state?
Discarding.
Discarding state. And assume itself as designated port, because both assume itself as root bridge. Okay, both sends proposal BPDU to each other. Both sends proposal BPDU to each other. Proposal BPDU is nothing else. The proposal bit is on that BPDU. Clear?
Yes, sir.
And claiming itself as root switch. Switch 1 is claiming itself as root switch, and switch 2 is claiming itself as root switch. Suppose the superior BPDU is sent by switch 1 based on its bridge ID. Okay? So switch 2 will stop sending proposal BPDU. It will send agreement BPDU. What BPDU?
Agreement.
Agreement BPDU. It will send agreement BPDU. And makes its port from DP to root port. Clear?
Yes, sir.
The switch which receives the superior BPDU now performs synchronization. What is synchronization? Suppose these are two another links of switch 2. Switch 2 makes all this port in discarding state. So that no layer 2 loop can form. Except the port from which superior BPDUs is received, all other ports of switch 2 moves to discarding state. Okay,
Hmm.
and the port which receive and send superior BPDU. That means this port sends superior BPDU and this port receives superior BPDU, moves to forwarding state. Clear?
মোটামুটি স্যার, এতটাও হলো না।
So let's take a brief look on GNS3. Enable configure terminal hostname switch 1. First of all, we will interface range giga ethernet 0 by 0 to 3, giga ethernet 1 by 0 to 3, shutdown, and enable configure terminal interface hostname switch 2, interface range giga ethernet 0 by 0 to 3, giga ethernet 1 by 0 to 3, shutdown. Debug spanning tree events. Debug spanning tree events in both switch. Debug spanning tree events. Okay? Now enable Rstp in both switch. Configure terminal spanning tree mode rapid PBST. Configure terminal spanning tree mode rapid PBST. See, nothing happened. Show spanning tree. No spanning tree instance exists. Okay? So now power on one port in every switch. Configure terminal interface giga ethernet 0 by 0, no shut. We'll perform this no shutdown at a time. At least try to perform at a time. No shut. So no shut, no shut. So what initializing Z0 by 0, it becomes designated, transmitting proposal on Z0 by 0, received superior BPDU on Z0 by 0, is now root port. Initializing G0 by 0, G0 by 0 is now designated, transmitting proposal. Okay? It will not receive any superior BPDU because this is the root switch. Show spanning tree. This bridge is the root. It is in learning state. In switch 1, show spanning tree. Clear?
Yes, sir. স্যার এই যে টাইপ লেখা আছে, টাইপে এটা কি এসএইচআর কি?
In GNS it will show shared, but in real time network you will see point to point.
আচ্ছা, হ্যাঁ পয়েন্ট টু পয়েন্ট দেখি ম্যাক্সিমাম।
Clear what I have said?
ইয়েস স্যার।
So there is exchange of 3 BPDUs only, okay? Actually there is exchange of 3 BPDUs, 2 proposal and 1 agreement. Okay?
হুম।
Do it again. Configure terminal, shut, configure terminal, shut, no shut, no shut. Show spanning tree. It immediately moves to forwarding state. Show spanning tree. It is in blocking state still now. Now it is in learning state. Okay.
ওকে, কিন্তু স্যার এখানে ম্যাক্সেজ এখনো 20 সেকেন্ড।
Yeah, it will show maxes 20 seconds. But it will not work. I will see in next class in case of topology change. Clear?
ইয়েস স্যার।
In how RSTP